Yes, students, we had parted the lecture and the logic was to make it more convenient for you. Okay, students, now we have to start with the ninth sum. Students, ninth sum LHS is equal to B plus C into cos of B plus C by 2. Now, concentrate for small b and c, students. Definitely we have to apply sine rule. So, k common sine b plus sine c into cos b plus c by 2. Now, students, what we will do according to the answer, in the answer we want a cos b minus c by 2. So, applying s plus s, we will get 2sc, 2 sine b plus c by 2 into cos b minus c by 2 into cos b plus c by 2. Now, this term is our answer. Check. So, we will not touch that term. Shift, flip-flop the terms. I am taking cos b minus c by 2 outside the bracket. Keeping k also outside the bracket. 2 sine b plus c by 2 cos b plus c by 2. Here the formula which I am going to apply is 2 sine theta by 2 cos theta by 2 is equal to sine theta. That I am going to apply with the bracket. So this changes to k sine b plus c into cos b minus c by 2, which is our answer. Now, students, answer is required in terms of small a. Now, all of you know, for triangle b plus c plus a is equal to pi. So, b plus c is equal to pi minus a. So, sine of b plus c is equal to sine of pi minus a. Sine pi minus theta is sine theta. So, this is k sine a into cos b minus c by 2. This is nothing but small a into cos b minus c by 2, which is our RHS. Therefore, LHS is equal to RHS. Hence, proof. Students, now question 10 is a very important sum, students. I am doing question 10, and students, that sum is again very important, sum number 10. Now it has some specific application of formulas, so let us first note down the LHS, which is a cos a plus b cos b plus c cos c. Sum number 10, LHS is equal to a cos a plus b cos b plus c cos c. Here we cannot apply projection rule because the angle and the side are same. In projections formula, you check these two differs. So what is the first step we can do here? Apply sine rule and write k sine a into cos a. Here k sine b into cos b. Here k sine c into cos c. Now, this step is the most decisive step. Multiplying and dividing by 2 sine a cos a, taking k common. 2 sin B cos B and 2 sin C cos C. Why? To apply the formula of sin 2 theta, which is 2 sin theta cos theta, I need to check sin 2x is 2 sin x cos x. To apply that formula, I need to. So I am writing k by 2 sin of 2a sin of 2b, and this I am intentionally keeping as it is. It will be justified in the next step. Now students, for these two terms, I am taking s plus s. What is s plus s? 2sc. 2a plus 2b by 2. So sin a plus b and 2a minus 2b by 2. So cos a minus b plus twice sin c cos c. Now a plus b is written as pi minus c, so this will change to sin c. That is why I kept these terms as it is. Now throughout 2 sin c is common, so what remains in the bracket? Cos a minus b plus cos c. So let us cancel this 2 and 2. Now students, very well you can understand that I have to apply the formula of C plus C, which is 2cc. And if I am going to apply the formula of 2cc, then the angles must match. If this term has angles A and B, this term must also have angle A and B. For that, we know that C is equal to pi minus A plus B. So cos C will be cos of pi minus A plus B, and cos pi minus theta is minus cos theta. So cos C will be replaced by minus of cos A plus B. So this is k sin C into bracket cos A minus B minus of cos A plus B. So now instead of C plus C, I have to apply the formula of C minus C, because our answer is required, students, in terms of sign. So C minus C will be minus 2ss. Addition of two angles is 2a by 2, so a. Subtraction of two angles is minus 2b by 2, so minus b. So minus minus becomes plus. This is 2 sin A sin B. Now students, we want small a. So k sin A will change to small a, and 2 sin B sin C as it is. So the final answer becomes twice A sin B sin C, and that is nothing but our RHS. Therefore, LHS is equal to RHS, hence proved. So, there are three decisive steps in the sum. First, multiplying and dividing by 2. The logic is to apply the formula of sin 2x, which is 2 sin x cos x. And second, keeping this as it is, to take sin 2 sin c common. And third, replacing cos c by minus cos of a plus. Okay, students, let us do sum number 11. Now, let us do, students, sum number 11. Cos A by small a. Sum number 11 LHS is equal to cos A by small a plus cos B by small b plus cos C by small c. Let us do, students, this sums. All of you pay attention now. Cos A upon small a, first of all check your RHS. Your RHS is required, students, in terms of small ABC. That is why it is advisable to do and apply cos rule. What is the formula of cos A? B square plus C square minus A square upon 2BC, and into A as it is. Here, apply the formula of cos B, A square plus C square minus B square upon 2AC into B plus cos C. So A square plus B square minus C square upon 2AB into C. So if you chart out, your LCM is 2ABC, which I am writing. Add the numerators, B square plus C square minus A square plus A square plus C square minus B square plus A square plus B square minus C square. 1 A square and A square cancelled, 1 B square and B square cancelled. And okay, 1 A square and A square, 1 B square and B square, and 1 C square and C square gets cancelled. So the answer is A square plus B square plus C square upon 2ABC, which is your RHS. Therefore, LHS is equal to RHS. Hence proved. Check this is a very simple sum. You get 3 marks for this type of sum. Okay, now students, let us do sum number 12. 12 and 13 sum has some specific characteristics which I am going to apply and explain. Students, sum number 12. B square minus C square into cot A. B square minus C square into cot A plus C square minus A square into cot B plus A square minus B square into cot C Now, this has, you can say, a specific characteristics. And what is that specific characteristics? You can check after B, we have C, after C, A. After C, A, after A, B. After A, B, and after B, C. This is called a symmetric type of sum. And in symmetric type of sum, we simplify only one term and write the simplification of other two terms. So let us start with B square minus C square into cot A. Now B square is K square sine square B according to sine minus K square sine square C, and cot A is cos A upon sine A. Now square b minus sine square c sine b plus c into sine b minus c into cos a upon sine a. Now all of you know b plus c is equal to pi minus a. So sine b plus c will be sine pi minus a, that is sine a. So this and this gets cancelled. So we have k square sine of b minus c into cos of a. So similarly, I can write c square minus a square into cot v will be k square sine of c minus a into cos b. If it is b square minus c square, it will be sine b minus c. If it is cot a, it will be cos a. So cot a is cos b. And a square minus b square into cot c will be k square sine a minus b into cos c. So applying this, we will take k square throughout common. So we will have sine of b minus c into cos a plus sine of c minus a into cos b plus sine of a minus b into cos c. Now apply the formula of sine b minus c, sine b cos c minus cos b sine c into cos a plus sine c cos a minus cos c sine into cos of b plus sine a cos b minus cos a sine b into cos c. Now go for simple expansion. So sine b cos c cos a minus sine c cos a cos b plus sine c cos a cos b minus sine a cos b cos c plus sine a cos b cos c minus sine b cos a cos c. Now check the sine b terms are this two, which gets cancelled. Sine c terms are this two, which gets cancelled, and sine a terms are this two, which gets cancelled. So final answer is k square into 0, which is 0. That is your RHS. So LHS is equal to RHS. Hence proved. Students, symmetry type of sums are 99.99% equal to 0. Symmetry type of sums are 99.99% equal to 0. I have parted the lecture in order to make you more comfortable and it is easy to understand. Remaining 4 sums we will complete in the next lecture to complete the exercise in the chapter. Thank you, students.